Hi everyone, today's video is just going to be about measuring DC current in a circuit. So I've got hooked up a battery here, my little switch for testing things in normal polarity or reverse polarity, so I can sort of use it for testing things like these solenoids or motors or whatever. I can run them forward or backwards, so you can see there that's from the battery goes into the forward reverse switch, and then that goes onto this cable which comes out as a pair of crocodile clips there, and into this car lock solenoid. So if I go forward, it goes out, if I go reverse, it goes back, and then it just relaxes in the middle. That's not driven either way when it's got no power. So you can't run these for too long with power because they're only meant to just quickly unlock and lock your car door, so they're not rated to have the current running through them for very long at all. If you do run them permanently on, that will burn out because it's effectively a motor in there driving a little gear, a little rack and pinion type gear, and that will just burn out if you leave it on for too long at all. So you've got to be fairly frugal with the time that they're on. So forward, reverse. So now how much current does this draw? Now I've got it hooked up to the battery because my power supply that I've got here on my home bench is only capable of, I think it's 2 or 3 amps or something like this. And with these solenoids pull about 5 up to 5 amps at full 12 volts. So that battery is probably not perfectly charged up, but it's not too bad. Now we can test this the current with a multimeter with a 10 amp range on it. So what you do is we'll turn that round to the 10 amp position, or the amps position I should say, and we'll move the positive probe over to the 10 amp socket there. So you've got to make sure when you finish using it, switch it back off and put it back in the volts/ohms position. Otherwise, if you leave it over in the 10 amp thing position and then go and put it across voltage or whatever, and you go to measure mains, you've effectively got a short circuit across those leads, so that's going to go bang big time. So across to the amps, into the 10 amp position, and then what we'll do is we'll interrupt the circuit. So we'll have nominally the positive coming in, going into the positive of the meter. Don't know how well you'll be able to see this on camera. Hopefully it looks like you should be able to see it there without too much of a shadow. And I'll just temporarily hold that there. This is only low voltage, so it's quite safe to operate like that. So I'll hold it there. So it's about 5 amps dropping off there because the battery's dying and dropping down in charge. And if I go the other way, we'll see it goes minus current, and that's dropping off again in current as the battery discharges a bit from being hit with a fairly high current. These are just old batteries I had that I use sometimes just for testing things. So that's one way you can test the current, like I said, on the amps range and in the 10 amp socket. And again, when you finish with it, turn it off and put that back over in the volts position before you put it away. Otherwise you'll grab it out next time and things will not be happy. Now there's another way you can measure this current, because the way we did it before with the multimeter leads, there is some drop in the multimeter itself, voltage drop, and you've also got the multimeter leads contribute to that as well, so the current reading might not be perfectly accurate. And what we can do is hook this back up again, so we'll just see that that still works. So what I've got here is a clamp meter. Now this one's a little bit different from the really common cheap ones, and then it's got DC current measurement. I don't know how well that'll come out. You can see there it's got a little DC symbol, which is the solid line and the dotted line next to or above each other on there. So you'll see that that's actually showing a reading there now. So because it uses a magnetic principle to measure the current, you have to be a little bit careful. It doesn't matter which lead we put this in, we'll just clamp it over one of the leads. If you clamp it over both, it won't work, so you need to clamp it onto one or the other, and it doesn't matter which way you do it, obviously. You know, if you had it like that, the reading will just be the opposite. Like if it's positive one way, it'll be negative the other way if you have the wire running through like that instead. So it doesn't really matter, because we're not interested in the sign of the reading, whether it's positive or negative. We just want to know the value. So, okay, so you'll notice that's got a residual reading on it at the moment. And that's because this type of instrument is sensitive to the orientation, and the magnetic field of the Earth does affect it. You can see it's varying depending on, I don't know how well you can see that, but it's varying when I start moving it around. So you've got to have to null that reading out. So there's a button called relative there. So I'll just get that back into camera shot. So that's reading like 0.5 of an amp at the moment, but there's obviously no current flowing. I haven't even pressed the switch yet. So I'll press relative, and then that'll drop down to pretty much 0. Now, even if I start moving it around now, depending on where I am there, you probably can't see that, but it's varying a bit now again. So it depends on the absolute. I'll take relative mode back off again. So basically you get it into the position where you're going to have it to do the measurement. Hold it steady there, press relative. Let's see if we can just null that out. So that's reading 0 now, occasionally 0.01. So that's got most of it nulled out, and then we can just press the button on this switch box. So you can see 4.5 amps. It's dropping down there because the battery voltage is dropping down, and the little motor in there is heating up, so that's probably increasing resistance a little tiny bit as well, which will result in further voltage drop. So and so we got a negative sign that way there, just because of the way I've got that hooked up. If I unclip that, and which way around was it? Was it that way? Hook it this way. We'll go forward again, and that's a positive sign this time, just from changing that cable around. So we'll see it's reading positive 3.6, 3.7 amps, negative 3.7 amps. So that's how you do a reading with a clamp meter that's got DC capability. If we go around both of them, and we'll just get it to where we can see it, we'll null that out. You'll see it's still got a small residual reading on there. It's hard to null them out exactly, especially on a cheaper meter. So that's pretty much 0 there. Now activate it, and there's no reading because the current flowing through one way through one wire is cancelling out exactly, because it's the same current going in and out of the solenoid. It's cancelling it out exactly, so you're not going to get a reading. So it doesn't matter which wire you do. You could even measure it right up here at the battery. So I'll see if we can get that in shot. So we're not measuring if you can't get to the wiring of the solenoid. If you can get to it at the source end, that's fine as well. So again, so you can see that reading. We'll just see if we can null that out. And then I'll press it, and we get our 3.6 odd amps there. It's going to give you the same reading no matter where it is, because it's all in one series circuit. So so this one's got a 40 amp range. It's also got a 600 amp range, so it's obviously for some serious current. It would be nice to have a clamp meter that did more accurate readings down in the, you know, maybe if it had a 10 amp range, that would be nice. But this is a 10 branded meter, and that comes from Element 14. I think that was probably about, I think this was on special for about $60 or $70 maybe, around that sort of figure. So part number on that is 72-9480, if that helps anyone who's looking for one of these. I did have a quick look on eBay, and you can get current clamp meters with DC ranges on them, like this one on eBay, for about, I think they were $45. If you see them around $20 or $30, they're probably only AC. You've got to be careful in the description, because they'll say they're a clamp meter AC DC, but in reality the DC bit only is referring to the fact that you can plug probes in there, so you can get standard meter leads with there. You can plug it into there and measure voltage. So if you go down to voltage there, you've got AC and DC volts. So the descriptions usually only refer to that part of it, not the current bit of it. So you've got to make deadly sure that it is capable of, specified as measuring DC current, because AC current is not going to work at all for the application here. So I hope you find that useful.